Automobile customers are demanding to have the linearity test for the instrument. So what is the linearity? Hi, my name is Pradeep Chavan and today we are going to see linearity test. Especially we are going to see the problem which is given the AIG manual and we are going to try solve this problem manually so that calculation will be clear to you. Okay, let us start. Let us start with the variation in the measurement system. First is related to accuracy, second is related to precision. Precision related variation can be studied by repeatability, reproducibility, CG/CGK. Variation related to accuracy can be studied by bias, linearity, stability, CG/CGK. So in this video, we are going to see linearity. So what is a linearity? It is nothing but bias at different operating range. So bias at various point of operating range, that is called a linearity. If linearity is problem, then there is a systematic error of the measurement system and that can be reduced, that can be eliminated. So systematic error is nothing but the error which can be removed. So instrument need calibrating maybe to reduce the error or the eliminate the error, improper calibration, so that may cause the error, worn equipment, temperature or humidity. So these are the reason. So first of all, we have to see how the study is conducted and what is the acceptance criteria for the linearity. So linearity is a accuracy or the bias over the range of instrument capability. So this is a first case where you can see linearity issues there. So if I measure the bias at initial stage, middle stage, last stage, end stage, so it is having increasing order. So bias is not okay. Rather linearity is not okay. Linearity is the issue here. In the second case, bias is seem constant everywhere in operating over operating range. So there is a no linearity issue in second case. I have taken here example from the AIG manual. So I have calculated the bias at over operating range. I have taken the reference value 2, 4, 6, 8, 10 and I repeated the reading at each reference value. I got an average and difference between average and the reference value is a bias. So I got a bias at initial stage, that is 49, then at 4 point this is a bias. So I got the bias and I draw the graph. X-axis is the reference value, y-axis is a bias average. So this is a graph. Now question is whether linearity is okay or not. Again, what is linearity? It is a bias at different range of the instrument. So now question is, by getting such kind of inclined graph, whether linearity is okay or not okay. So that we have to see by calculating all these things. Now coming to the gauge linearity calculation part, a reference value I got. So I have to take the reference value average. All these things are added together, divided by total number of the values. Same thing is done for the bias. So I got a bias. I have to again calculate the average of the bias. Then reference value deviation for the this particular column, that is column 1. So first value should be subtracted from the average, that is 2 minus 6, that is minus 4. 4 minus 6, like this way this reference value deviation is to be calculated. Similarly for the average bias, this value should be subtracted from this average. So this value I got from this formula. Now deviation product. Now you have to multiply these two column, this reference value deviation and average bias deviation. You have to multiply and you have to take the average of this. Now reference value squared. Now you have to square this reference value. So minus 4 into minus 4, that will be 14, 16. So again you have to add this together, that will be 60. Now from this value you have to calculate the slope. How slope will be calculated? Formula for the slope is this. Now this is a deviation product, summation of deviation product. Here you can see that is a minus 0.26 here, and this denominator is a reference value square, that is 40. So after calculation you have got this slope, that is minus 0.13. So even from the Excel sheet you can cross check. So here you can see same slope is got by Excel calculation. Now I got a slope. Now I need to calculate the intercept for the line. Slope and intercept is required. So this is the same table from the previous slide. Now equation of line y equal to b0, that is intercept, plus b1 x. So b1 is a slope. Now if I take b0, that is intercept one side, then I will be getting y minus b1, that is slope, into x. Now b0 equal to y. So what is a y? That is average bias, that is a minus 0.0533. This minus this 0.13, minus 0.13, that is a slope which I already got, into x. So what is the x? That is a reference value, average, you know. So all these value added together divided by n, that is a 6. Now b0 I got 0.736667. So this is a b0 or intercept. Slope I already got. So I got the regression line. So this is the slope of the, this is the equation of the regression line. So here I got the intercept calculation from Excel sheet also to cross check. Now you can see these value are matching. So our calculation is right. Now question is whether this regression line is accepted or linearity is accepted or not. So let us see in the next slide. Now this is the acceptance criteria. For the intercept t static constant, or rather value, I got this, for which p value is 0.0023, and for the this slope t statistics is minus 11.52, for which p value is 0.001. Now at a 95% confidence level, required p value should be more than 0.5. So right now which is appearing less than 0.5. So that means our null hypothesis is rejected. There is a problem in the instrument. So instrument is to be repaired and recalibrated. Are you getting me? Okay, next slide we will see in the pictorial form so that the thing will be more clear. So this is a regression line equation for which intercept t statistics this value, p value is this. For the slope this is the t statistics and p value is this. Now see, we are assuming null hypothesis is okay. So we are assuming that value of the t should be lying in the non-rejection zone. So for that I need to calculate critical value. As per the t statistics table, I got the critical value 2, that is a minus 2 left side and plus 2 at the right side. Now see, intercept t static is 9, so which is lying in the rejection zone, and it is not lying in the non-rejection zone. So my null hypothesis is rejected and alternative hypothesis is accepted, rather adopted. So it is far away from the 2, it is lying in the rejection zone. Similarly for this minus 11, that is in the slope, it is lying in the rejection zone. So my null hypothesis is rejected. So instrument need to be calibrated, rather repair and recalibrated, as linearity is a issue. Some kind of causes are there which are to be removed, which are to be repaired, and this is how this linearity test is to be conducted and calculation is to be made. So thank you very much for joining this session. Thank you.